Hi, my name is John Newman, and I am a security systems engineer here at Cisco. Today we're going to talk about tetration, specifically the scopes, roles, and users and how they are implemented within the system. So as a quick reminder of tetration, it is our system that ingests and analyzes traffic within your network, typically around cloud infrastructure as well as your data centers. So we're not looking just north-south, but we can also see the east and west traffic. So to be able to microsegment out your actual inventory, we have created these scopes, and to be able to manage the scopes, we have created roles. So first, let's go ahead and start taking a look at scopes. Scopes define a hierarchy that should mimic the asset ownership hierarchy of the actual organization. So scopes are used to define applications and workloads and put them into actual groups. Roles, they define user access to those scopes. And then finally, users, they're assigned to those roles. So it is a RBAC type of situation. So if we look into the actuality of scopes, we always start off with the root scope or the default scope, and it is always defined by a VRF ID. So in this case, I just put X. But then within that, we can have a scope of either your different data centers, or however you want to kind of split them up. We typically do recommend to split them up by the data center. But in this case, we have DC1 that is starts off with the 10 network, DC2 and then 192, and DC3 within the 172 network. So building off of that, we can start building that hierarchy system. So now within DC1, we have another split of the scope going to the infrastructure. And that infrastructure is now going to be within the 10.64.0.0 network. And then within that, we can actually start pulling out applications that have the host names that contain -eng- for the engineering group. So now we have created a scope at the top that is default DC1 infra eng. So within that scope, a endpoint is actually going to be matching. It has to be within that 1064 network, and it has to have the actual host name that contains the ENG. So we can start splitting up those scopes a little bit more. So in this case, we've now, within that infra scope, we can actually create another child scope that is the dev sequence. So within the infra that may not have the host or that will not have the host name of ENG, we could have a whole slew of other hosts that live within a specific subnet. So in this case, we have everybody that is in the 10.64.128.0 network is a dev address. So now we have two overall scopes. In this case, we have the default DC1 infra eng, which will have the VRF ID it will have the VRF ID defined within the default scope. It will be part of the 10.64.0.0 network, and it will have the host name of eng. The default DC1 infra dev scope will now have most of the same sequence, but instead of having the host name, it's going to be specifically within the network of 10.64.128.0. So almost everything is assigned a scope for RBAC control. So we're talking about inventory filters, applications, workloads. Data is restricted to scopes. So a flow search within tetration, the inventory filters within tetration, or the applications that are discovered through tetration, all of that it has to be restricted within a scope. So basically, it's a way to segment the devices within your network so correct users and admins can troubleshoot, view, or edit the devices that they are allowed to control. So as a quick example, if you have an admin over the engineering data center, he or she is allowed to have full access to the engineering data center, but should not have access to the finance applications. So we can define the scopes to ensure that he or she cannot view those those finance applications and the finance flows, but should be able to view all of the engineering. So now, if an engineer server is reaching out to a finance application, that engineering admin can see that traffic. So a scope does involve any and all traffic that is coming in and out of that specified workload. A couple notes when it does come to scopes in themselves. We once they are created, and once they are created, they cannot be edited. Only child scopes can be deleted. So if you have a hierarchy view, in this case, we cannot delete the infra scope until we delete out the engineering and the dev scopes. And scopes with applications or policies or inventory filters that are applied to them cannot be deleted. Another note as well, hosts can only be part of one application. So scopes are used to define those application workspaces. Let's take a quick look at how we can actually create a scope. So here we are within Tetration. I am not a full system admin user, and I am within the pod 105 scope. So if I click that here, we can see that I have access to the pod 105, and then within that I have the open cart. So to be able to define scopes, what we can do is actually come up over here to the little gears in the top right, hit scopes, and it'll bring us to our scope list. And you notice I'm back at my default 105, and I can see the open cart here. So to create a new scope, just come up here to the corner, create new scope, and we will mimic what we did before where we had DC1 as the actual name. We're going to have the parent scope be 105, and here is where we can start applying our queries. So if I just type in A for right now, you see a full list that pops up, and we can see we can use addresses, address types, scroll through, we can see host names, specific data centers, packages. In this case, we're going to settle on the address, and we want it to equal, and in this case, we're going to put in, I don't want to overlap anything that's already in our system, so I'm going to put 1.1.1.1.0, and we're going to have that as a /24. So we will create that. If you notice, it immediately pops up, and we are within the pod 105, and we see the DC1 with our query to it with no children. So let's go ahead and create those children. We'll create another scope. And if we continue with our example, I'm going to go ahead and skip the infra, and we're going to create the eng group. So instead of 105, we are now going to apply this under the DC, and we can actually go ahead and create that host name that contains, and we want it to contain that -eng. So we'll create that there. And now we can see that this is modified by DC exclamation point and the owner with one child. So we're going to create another scope. Continue on with this example, head under DC1. But if you notice here as well, we could go under engineering to continue that hierarchy, but we want to split these guys up. So we want devs. I'm going to create the host name is equal to dev. And let's go ahead and create that there. So now you'll notice that this now has two childs, and we want to see if we want to see what those children are, we just click onto the name here. And now we are under the pod 105 DC exclamation point, and we can see that we have the children of dev and eng with our different queries. So in this case, if I have a machine that is specifically hostname has dev, or in this case, this one contains a -eng, and that will start splitting up our pieces. Okay, so next we want to talk about the actual roles. So if we remember, we have our scopes already defined, and our roles are now used to define those user access to those scopes. So a role actually consists of a scope and the ability, and the ability provides the user with the action of what they are able to perform. So if we look at those abilities, we have read, which you can view things. We have write, in which you can change things. Execute, where you can perform actions that take cluster resources. So whether you're running a policy analysis or pushing out the ADM rules, you have the enforce, where you are allowed to update the firewall rules on the actual hosts. And then you can be the owner, which in case you can do things that actually impact across that entire scope that you're the owner of. So all the abilities are inherited. So if you are the enforce, if you are assigned the enforce role, you have the ability to read and write, execute, and enforce. So if we take a look at what we had before, where we have DC1 and now we also have DC2, which are very similar setup. They both have engineering and developing platforms inside of it. So what we can do here is that user one can be assigned at the default level has read access. So what that means is that that user will have read access to everything below it. At within default, or if we go into default DC1 and DC2 and assign him as an owner, that means that he will have full access to be able to manipulate anything within DC1 and DC2. But if there is a DC3, he will not have access to that, but he will be able to read it. User 2, we assigned it as owner to the engineering platforms within both DC1 and DC2. So what that means is that that user will be able to change anything about the engineering piece. But if we if he takes a step up or goes over to the dev side, he or she will only be able to read it. So they will be able to read those actions among the dev side or the full infrastructure in this case, but will be able to modify anything when it actually comes to the engineering host. So okay, if we hop back into Tetration and we want to create those roles, so we come up here to the gear and we'll come down to these roles. Now, mind you, again, I am the admin of the pod 105, where we can imagine that that is the default in our example. So if we create a new role, we're going to create this, and we want this to be, let's say, the engineering admin from here. So we're going to say 105 eng. It's just the name. We can put in a description. Let's go ahead and click next from here. So now we need to add those capabilities. So that's that second part of the scope and role category. So let's add that capability. In this case, this is our default. That's our top end. Remember from here. And the ability that we want here is just to read. We want to be able to see what's going in with our role. So we're going to add that in there. And we can add in the next capability. So say what we wanted here was that within the infrastructure, which we don't have right now, but we can put it down into the actual engineering piece of it, that we want them to be the owner of that section. So now we will have read access to the pod 105, which then gives us the access to read the DC1 level, and we will have the owner access down to the engineering level. So now we will be able to read down to the engineering and be able to modify anything with the owner. And also, since we do have that pod 105 read, we will have read access to that dev account as well. And now you can see here, this is just explaining everything that we just had, and then we can go ahead and create that. Now to be able to create a user, hop back up into this gear section as well, come into the users, and we'll create a new user. So in this case, we want to put in an email. So we'll click next there. And now we need to assign it to a role. So we can come in here and we can actually assign it directly to the role that we had just created. So now that they will have read access to pod 105 and they will be the owner of DC engineering. And if we had DC2 configured within here, we would be able to do DC2 engineering as well. So now we can see that we're creating that user directly to that, and we can go in from there. So now we have that secondary user assigned directly to that, and we'd be able to Once the full user creation is done, we'll be able to log in as that user to be able to view that engineering side of things. So now let's talk about the user roles, those that are predefined within Tetration, those that are site admins that can modify everything with it would be able to view these. As within our demo environment, remember I am only a member of that pod 105 from right now, so I'm not able to view all of these predefined roles. I would have to create each one of mine individually. But in this case, we are able to create specific user roles that are based off of predefined definitions. So we do have a couple of them here. We have the customer support, we have site admin, lab user, global application enforcement, global application management, and global read-only. So users can have more than one role, and site admins can remove their own site admin role. So as a quick overview of each one of these, the customer support, this is similar to if you for Cisco TAC. So if you have support coming in to help you out, or if you have somebody that is just there um, to give them enough access, but we don't want them to edit things, that would be customer support. But they cannot edit users. They can edit roles and scopes. They do have access to all the debugging tools, and they are the owner of all scopes, so they can see everything, do everything. Basically, they are a site admin. They cannot do um, user management. So the site admin, this is the what some systems will call a super admin, but it is the only user who can actually manage users. So they can also access debugging tools. They are the owner of all scopes. And they can do mostly everything. And there always has to be at least one. So remember, a site admin can remove themselves from being a site admin, but there always has to be at least one. Then we have a lab user. So there is a specific tab within the newer versions of Tetration that is for lab use or ad hoc use. We typically recommend to have this user assigned with another role as well, so they'll be able to view the cluster and view the inventories. But this will allow them to actually have access to that specific tab. There's also the global read-only, fairly simple. They have the ability to read all scopes that are defined. And finally, we have the global application enforcement and global application management roles. The enforcement can enforce all the all the ability or enforce everything on the scopes, versus the management can only execute all the abilities on these scopes. So thank you for taking the time to watch and listen to this, and I hope we talk again soon.